Okay, just 3 more examples to go through. So we got x to the 2/3 minus 1 over x squared plus 1. Now you got to think, what does this actually look like? So you guys remember the trick that we used to do when we had something like this? We would rewrite it with negative exponents. The nice thing is that this applies for this stuff as well. So we can rewrite this as x to the 2/3 minus x to the negative 2 plus 1, and then go through and use our power rule, figure it out. Okay, so power rule applied to 2/3, so we do 1 over 5/3 because we're adding 3/3 to it, so I got 1 over 5/3 times x to the 5/3 minus, got to add 1 to negative 2, so it becomes negative 1, and then I'm going to multiply by 1 over negative 1, so I got x to the negative 1, figure out what our end term is, and then I got plus 1x, and then I can add my c value, and then I can rewrite this, and let's label this big F of x is equal to, okay, so simplify this a bit, I get big F of x is equal to 3/5 x to the 5/3 plus x to the negative first, but let's rewrite it as 1 over x plus x plus c. And now you can go through and evaluate it and find points and all this fun stuff because it looks so nice now. All right, example 8. This one gets more complicated because I got this trig function in here, which are very, very difficult. Okay, so I got f of x is equal to 2 over x plus 3 sine of x. If I want to simplify this, I can break it apart, look at one piece and then the other piece. Okay, so let's look at this 2 over x first. Well, it's going to be 2 times whatever the antiderivative of 1 over x is. And luckily we know that this is the natural log of the absolute value of x. Plus 3 times the antiderivative of sine of x, which we already learned was negative cosine of x, and throw that plus c on the end. So this is big F of x is equal to this nonsense. And then we can do some simplification and rewrite it as 2 natural log of the absolute value of x plus, not plus, simplify it, don't make it just as complicated, minus 3 cosine of x plus c. And this is f of x, well, big F of x. All right, one last problem to go through and do this crazy nonsense just for the sake of it. Really, it's not that bad. What was the antiderivative of secant x tangent x, and what was the antiderivative of secant squared of x? Well, the antiderivative of secant x tangent of x was just secant of x. So big F of x is equal to secant of x. And then what's the antiderivative of secant squared of x? Just negative tangent of x. And put our plus c. That one actually wasn't bad at all. As a matter of fact, it was so easy. Let's do example 10. Yeah, that's right. There's another one. Okay, example 10. Let's do x to the 3rd plus x squared divided by x is equal to little f of x. And let's find big F of x. Well, these kind of problems here, you may think, oh boy, we're going to learn a quotient rule now. That's backwards. But for these ones, we aren't. Okay, so quotient rule is kind of messy, so let's not do that. Let's rewrite this as x to the 3rd plus x squared and put each of these over x. And this simplifies to x squared plus x. And then if I want to go through and take the antiderivative of this, big F of x is equal to x cubed over 3 plus x squared over 2. And this is your final answer there, which is pretty great. Okay, so there's all the notes. You guys try the homework. Good luck with it. I'll see you guys hopefully on Friday, but you never know. You never know.